Why is America spending billions on chips people call old? Because the most advanced processor cannot manage a motor, read a temperature sensor, or regulate power by itself. Those jobs often fall to analog and embedded chips built on established processes. In December 2024, Commerce awarded Texas Instruments up to $1.61 billion for 3 U.S. fab projects. The words "up to" matter. This is milestone-based funding, not cash paid on announcement. Policy language separates leading edge, current generation, and mature node capacity. NIST program materials place logic, analog, mixed signal, discrete devices, optoelectronics, and sensors across the non-leading edge categories. That list is the clue. Mature is not a universal score for product quality. A process can be older in geometry and still be the right tool for high voltage, precision, reliability, or a long product life. Texas Instruments says its analog chips condition real-world signals such as sound, temperature, pressure, and images, while embedded processors provide control. Its recent process development for much of this portfolio has focused on 45 to 130 nanometers. That is a company-specific choice, not a rule for every chip maker. Smaller geometry can add cost without improving the voltage, power, thermal, or precision needs of a particular analog function. Then comes wafer economics. Texas Instruments' 2025 annual report says an unpackaged chip built on a 300mm wafer costs about 40% less than one built on a 200mm wafer. That is the company's estimate for its manufacturing model, not an industry constant. Larger wafers carry more die, but the fab, tools, labor, energy, and depreciation remain expensive. Cost advantage appears only when the line yields and stays productively loaded. The federal deal supports more than $18 billion of Texas Instruments investment through the end of the decade across 2 Texas projects and 1 Utah project. In 2025, the company separately expanded its long-term U.S. plan to more than $60 billion across 7 fabs. Do not merge those numbers. One describes projects tied to the award. The other is the company's broader announced manufacturing plan. Public dollars are a fraction of the full capital stack. The payment design tries to turn a ribbon cutting into accountable capacity. Commerce says direct funding is distributed after construction, production, and commercial milestones, with financial and program reports. Texas Instruments' 2025 filing still described up to $1.6 billion in milestone conditions, including possible clawbacks. The policy test is usable domestic supply. The business test is whether customers buy enough output at prices that support the factories. One important milestone is already real. Texas Instruments said its first Sherman fab, called SM1, began production in December 2025, 3.5 years after groundbreaking. But production start is not the same as full output. The company says the fab will ramp with customer demand. That distinction keeps us from treating a construction announcement, first wafer, and a fully utilized factory as the same economic event. Foundational chips are also not interchangeable. Automotive parts may follow a ECQ 100 qualification, and major process changes can require qualification plans, test results, and customer notification. Different voltage, package, reliability, and process requirements create different approved parts. So a headline about aggregate wafer capacity cannot prove that a buyer has a second source for the exact component. That conclusion requires product-level evidence. Demand is the second boundary. In July 2026, Texas Instruments reported quarterly revenue up 23% from a year earlier, with broad growth led by industrial, data center, and automotive. That is a current data point, not a guarantee for the lifetime of 7 fabs. Capacity takes years to build. Demand and inventory can change faster. Track factory ramp, inventory, lead times, customer qualification, product mix, and capital spending before calling resilience profitable. So why subsidize so-called old chips? Because resilient systems need both computation and control. Leading-edge processors create digital capability. Foundational chips connect it to voltage, motion, temperature, sound, and safety. The disciplined conclusion is narrower than the headline. America is not replacing advanced chips with mature nodes. It is paying to reduce a supply chain weak point, while companies still must qualify products, fill factories, and earn returns.